This is a short video to explain the basic features of lines. What we'll look at is setting up a quick initial design project and a lines project, using PACE for interactive design where we will define and modify curves and then create a simple curve network. We'll refine the mesh, look at knuckle and tangent curves, controlling the tangent curves with angle curves, and then look at high quality surfaces. So starting out, we'll create an initial design project. In initial design, right click on a folder, new project. Give your project a name and select somewhere to store the data. Now we need to fill in some approximate dimensions. These allow lines to understand how big your ship will be and where to find the midship section, if that's required. You can always update these dimensions later in this tool or in the local application. Once you've created the project, right click and select. Now we'll create a new project in lines. So go up to the new, file new, and just create a new file, press the new. We will now go into PACE, the patch and curve editor, where we will do the majority of our interactive design. To start with, we'll need some views that we can work with. So we'll need an orthogonal view that looks along the bow, and we'll set up a grid that's spaced between 0 and 10 where we'll draw some simple curves. So now we'll start some curves. Start by creating a curve. So we'll go up to the new curve tool, create a freehand section located at the x equals 0 plane. To put some points in, we just click in the view, pressing escape once we're done. Let's modify the curve. So we can do this by manipulating the points. We may need to switch into curve modification mode. As we select a point, we can see that the data points are highlighted in yellow. We can change their coordinates. We can of course interactively manipulate the points on the screen. Now let's look at the tangents on data points. So tangents or data points can be changed by pressing the tab key. The tab key will run through the sequence of different options. So the first option is a simple tangent, and then we'll move into different knuckle options, one with 2 tangents, a tangent on one side, the other side, and a knuckle without any tangents, the tangents automatically being automatically calculated. We can also set the tangents using the drop-down menu. Notice that if a tangent has a specified vector, that the angles of that vector come to the right in the list. If a point has 2 tangent vectors, then there's 2 sets of angle coordinates. Let's now insert and delete some points. To insert some points, select the curve and use the Insert Point tool. You can insert points anywhere you want along the curve. Press Escape to finish. These points are now available for editing. To delete press the delete key. To select more than one point, select first a point and then draw a fence. Let's go back to have a look at autotangents next to the curve ends. So by specifying an automatic tangent, this will create a linear segment next to an endpoint, like so. The tangent on the other side of the automatic tangent picks up the same direction as the linear segment, and you can see that quite easily we can create the style of a ship shape midship section with the flats or a keel. Autotangents also work with knuckles. So we have a knuckle in the middle of the curve, and an autotangent alongside will create a linear segment towards the direction of the knuckle. In this case, that could be, for example, a keel and then rise of floor. Introducing straight segments into your curve. For a straight segment, select 2 points and press the straighten curve button. This introduces 2 tangents where their tangent vectors are aligned. If you move the points away, you will have to reapply the straight segment. Segments with arcs in them. These instructions need to be followed quite closely. The arc tool works either side of a knuckle point. We will set this curve up to be a midship section with coordinates at 0, 0 and 10, 10. We will set a knuckle point up at 10, 0. To bring up the arc tool, first select the curve. Do not select a point. It will fail if you select a point. So the arc tool is this circle. We can move this circle around. To set a radius, we right click on options and change the value. We then position the arc tool so that it overlaps the curve at 2 points either side of the knuckle. We right click on the curve of the arc curve and snap it. Once done, we can now modify the curve. Now we will use curves to form a surface using a curve network. So deleting the original curve will now create 3 sections at x equals 0, x equals 5 and x equals 10. The first and last points of this curve need to be placed on the y equals 0 and z equals 10 plane respectively. This is so we can link them up with simple planar curves after we've drawn these curves in. So now we have 3 sections reminiscent of a ship hull. We will now connect these together with a buttock on the centre line and a waterline near the top. Make sure that we intersect the curves that we choose. We must now look at this in 3D. So we can see here the buttock connects those 3 curves together. Now for the waterline, if we don't know the position, we can go and select a curve to get the coordinate point. So here, selecting that point, going to the new curve tool will pick up the coordinates of the selected point beforehand. Now we have a connected curve network, we can generate a surface. We may change the data points to give a sampling density of 10, but this will not be needed until we look at high quality surfaces. So now we've generated the surface with the magenta side on the inside and the blue side on the outside. Using the isophotes we can check the fairness, which in this case is not particularly good. We will address that as we go through this video. So now we will refine the network to reduce or increase the number of patches, and we'll do this by adding a diagonal. We'll introduce a C-line, which is a 2D curve in a particular plane. Effectively, this is representing the diagonal plane. The purpose of this is that we define an intersection shape that we can project through all of the curves, picking up data points, producing a new curve. In this case, a polyline. So we're going to project that curve right through the sections, and it will pick up coordinates, which will form a curve in 3D. C-lines can have as many data points as you want. They do not necessarily have to be planar. So there's the original surface. We'll regenerate. Now we have a 2x2 set of patches. The curvature is slightly improved, but to take it further we need to introduce the tangency constraint. Now the surface is a little bit more improved, but not perfect. This is good for concept holes where we don't want a lot of data and we want to change things quickly, but later on when we look at high curvature surfaces we will end up generating a lot of data that will be difficult to change. So we'll refine the surface further using the mesh tools. The mesh tool is up on the toolbar. This considers the curves to be connected together so we can move the whole network at the same time. Red points are disconnected. If we right click, we can connect them together. We get a green point. We can connect more than one, selecting a point and driving a bigger selection. So now when we manipulate these points, we manipulate all the curves that are connected at that point. Let's look at that in 3D. So now when I manipulate a point, you can see not only does it continue to lie on the diagonal plane, but the whole data set behaves as if it was a mesh, like a B-spline surface. But in this case, because we're dealing with individual curves, we can have an irregular network. As we're going through this process, we may generate the surface at any time. As we manipulate the points, also notice that we have the curvature displayed as well. Now we will look at what the effects of knuckle and tangent curves in the curve network. We will take our diagonal and convert it to a knuckle line. This will give us a corner of the surface. Effectively, we will just change its type here. We will not see the effect until we refit the sections. We can now regenerate the surface. And we can still manipulate the surface as a mesh. In this case, we'll now change the knuckle to a tangent, using the same process. nothing will happen until we refit the sections. When we do this, and the tangent has no further information, the sections behave as though a autotangent was placed on them at the point where the tangent intersects with them. The opportunity to edit with the mesh tool remains. Now we will use an angle curve to control the shape of the surface along the tangent curve. We can only create an angle curve in lines. To do this, we go to the angle part of the tree and press create. We select the tangent curve that we want to add to. We will pick up its shape from any intersecting sections, generating these coordinates automatically. Here we see the data points. We now need to fit a curve through these points. To complete this, we'll accept the curve, and then we can return to pace to edit the curve. We will get a new view so that we can see the coordinates of the angle curve because its values are slightly greater than the surface that we've worked with. We see the angle curve up there. So we can manipulate its coordinates in exactly the same way as any other curve. Let's set the ends to a horizontal shape of 0 and the middle to a vertical shape of 90. We may have to change the fitting algorithm because there are some quite extreme values which a normal fit does not behave so well. Again, we will need to refit the sections to see the effects of the angle curve. So the end curve's a 0 angle, the mid curve is vertical. We update the surface. Now we will reduce the extremity of this change to 45 degrees at the ends of the surface. We follow that by updating the sections and regenerating the surface. This type of feature is very useful for controlling the tangency of a hull surface, say for example leaving the flatter bottom or leaving the keel. It's much easier to do it this way and get a smooth result than manipulating control points of a surface. Now we'll look at high quality surfaces. So we saw the quality of the surface we produced earlier based on the tangency. To go further, we need to remove that effect. High quality surfaces in lines are achieved by fitting the surfaces to the hull contours. Hull contours we will generate using a process that will achieve great smoothness. So first we'll create some sections that use a similar model to the section that we've already created. We will follow that by fitting water lines to the existing curves that we created, and then buttocks to all the remaining curves. If the process that we've used creates a smooth surface, then these curves should be smooth. We may see unfairness appear at this time, and we should try to eliminate that by creating a better process. If we fit a surface now, as every curve is equal, it tries to create a lot of small patches between the gaps. This is not the effect we're looking for. We're going to turn off these additional curves, have them displayed only as dotted lines, and the system will use them to fit the internal shape of the patch using the existing curve network that we created at the start of this session. So the original curve network and the dotted lines are the new curves. Now we will use the data points and making sure that we use all the curves that we've created. At this stage it looks fairly smooth, but still we have a slight discrepancy there. This is because we're still using some additional calculations, and here we're using the smoothing. By removing the smoothing, we just take the data points, and now we see we have a very smooth surface. So this is a summary of what we've covered in this video. Thank you very much for watching.